Welcome to our section 1.5, Measuring Segment Notes. We're going to be looking at segments and how to figure out the measurements for each part of them. So this first statement is if A, B, and C are on a segment, then AB plus BC equals AC. So here's your A, B, and BC, and it's saying that AB plus BC would equal AC. So let's take a look at a couple examples. First of all, we want to find the measure of the segment. So in this case, we want to find the measure of the segment XY. So if we look here, we know what XT is equal to, 3.2, and TY is equal to 5.7. So if we go back up here to this statement that AB plus BC equals AC, we should be able to just add those together. So again, XT plus TY equals XY. So in this case, 3.2 plus 5.7 equals 8.9, which is equal to XY. In our next example, we would like to find FG. We're not given the same information for this one. For this one, we don't know what FG equals, but we do know that GH equals 13, and we also know that segment FH equals 29. So we can set this one up same way. FG plus GH equals FH. So if we plug in these values, we don't know what FG is, but we do know that GH equals 13, and we also know that FH equals 29. So if we just keep this FG here, then all we have to do is solve for FG. So how we would do that is subtract our 13, and that will tell us that our FG equals 16. So that's how we find the different portions of the segment, and we're going to look at a few more examples. On this page, it is telling us that congruent segments and midpoints, so if we look down here, congruent segments have the same measurement. So here is our segment. Once again, EF equals 3 centimeters, as does FG. They both have the same measurement, 3 centimeters. So these two segments are considered congruent. So we write EF is congruent with FG. For a midpoint, that is a point that divides the segment into two congruent parts, meaning that that midpoint divides the two in half and they are equal parts on both sides. So anytime you see midpoint, it means that you have equal portions on each side of that midpoint. Here are some more examples. If DF equals 46, we need to solve for x. So we can see here DE equals 2x plus 3 and EF equals x plus 7. So we need to write down what we know. So we know that DF equals 46. So that's the complete segment. So how we can figure this out is by setting up 2x plus 3 plus x plus 7 equals 46. And to solve for x, we need to combine like terms. So then we would have 3x plus 10 is equal to 46. And if we go one step further, we could say 3x equals 36 if we subtract that 10 off both sides. And then we're left with dividing by 3, and that gives us that x equals 12. We're not quite done yet because in our next step it says what is the length of DE and EF. So to solve for those, all we have to do is put this 12 back in for x, and that will tell us what each is. So DE would be equal to, if we plug the 12 back in, 12 times 2 would be 24, plus 3 would give us an answer of 27. And EF, again, we're going to do the same thing. So x is 12. So if we plug that in, 12 plus 7, then we get the answer of 19. So that's what you should have for your answers there. Number 2 is set up a little bit different. For this one, it says C is the midpoint of AB. So we can say AB. And it is telling us that C is the midpoint, which means each of these sides are equal or congruent. So it wants us to find AC, CB, and AB. So to do that, it's similar, but for this one, we're going to set these two sides equal to one another. So that will look like this. 2x plus 1 equals 3x minus 4. And when you do that, we're going to, again, solve for x. So go ahead and try that. Okay, we should have that. And now I want to add 4 to the other side, which gives me x equals 5. So we've solved for x, and the other step was we need to find AC, CB, and AB. So again, if we plug 5 in, we know that 2 times 5 would be 10. And if you add your 1 to it, that means that AC equals 11. You can plug your 5 in here and figure this out, but we know that these two sides are congruent. So if AC equals 11, then CB is also going to equal 11. To figure out AB, which is the total distance, we can just add these two together. So AB is going to equal 11 plus 11, which is 22. And that's how we would solve for that. For the last one, it says find x and mn if n is between m and p. mp equals 60, mn equals 6x minus 7, and np equals 2x plus 3. Draw and label the picture. So I'm going to pause the video and you see if you can set that up. All right, hopefully you've had enough time to set that up. You should have started by drawing this picture. It said that n was in the middle, but it did not say that it was the midpoint. So we should know we can't set them equal to each other, but we did have the information that MP equaled 60. So we still had enough to set this up. So I drew everything out, put the P at this end, N in the center, M here. We knew that MN was 6x minus 7. NP, it was given, was 2x plus 3. So over on this side, I set up the equation 6x minus 7 plus 2x plus 3 equals 60. Then you're simply going to try to solve for x. So I combine my like terms. So I have 8x minus 4 equals 60, added 4 to each side. That gave me 8x equals 64. So I divided by 8 to finally come to x equals 8. We weren't quite done yet because up here it told us to find x and mn. So we found x is equal to 8, but then we just have to plug that back into mn because that was the other portion it wanted to know what mn was equal to. So to do that, we just take our mn equals 6x minus 7, but we're going to plug in the x value, which is 8. So 6 times 8 is 48 minus 7, so mn equals 41. For this one, we've got to use our midpoint formula, which right here is x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. It doesn't matter which coordinate you use as your x1, x2, or your y1, y2. So I set them up. This one's x1, y1, x2, y2. Then you just plug them in to the equation. For this example, this is what we get. And when we solve for that, we find out our midpoint coordinate is 1/2 and 4.5 for our y coordinate. So x coordinate is 1/2 and y is 4.5 is our midpoint coordinate. In this last example, we're going to use the distance formula, which is here. The square root of x2 minus x1 squared plus y2 minus y1 squared. So we have to plug in the values. This first one is our x1, x2, and then our y1 and y2. So you plug those values in. So we've got our x2, which is 7, minus 8. So since it was minus, it becomes a positive because it was minus negative 8. Then we have negative 3 minus 3 squared. We still keep it under the square root, but we figure this first part out to be 15 squared plus negative 6 squared. Still under the square root, that gives us 225 plus 36, which gives us a square root of 261. When you take the square root of 261, it gives us that our distance is approximately 16.2. So this is how you use the distance formula. These values would be given to you, and then you have to plug them into this equation to figure out what your approximate distance would be. And in this case, it was 16.2. All right, so that's it for measuring segments. And these notes also included the midpoint formula and the distance formula.